Welcome back. Todd June with OP-TEC, the National Center of Optics and Photonics Education. Today we're working on Laboratory 2-8, and the priorities here is to look at the power output, looking at beam characteristics, as well as measuring divergence of a continuous wave impulsed neodymium YAG laser. Today I'll be using the diode pump solid state neodymium YAG laser, and if you're using an arc lamp laser, you probably want to take some extra precautions just because of the higher power. If you look at our laser cavity, we have a diode pump laser, we have a collimating lens, a focusing lens, we have a neodymium YAG rod with a highly reflective coating, we have an output coupler, we have a lens holder with an RG1000 filter, and we have a holder with a photodetector with a shunt resistor and a BNC cable going to our oscilloscope. Now that we have our laser lab safe and secure, let's talk about the laser power supply. You'll notice in the upper left hand corner is a key switch, so I can turn the laser on and off and secure it when I'm not using it. Next to the right of that is the laser modulator, and we want to make sure that we have that mode turned off. Next is our laser temperature, and we'll be setting that at 25 degrees Celsius for these labs. And on the bottom of the power supply we see a controller for the photodiode. Let's make sure our gain is set to 1. And we can adjust our laser current. So let's turn our power supply on. Make sure you have your laser safety glasses on. I want to turn the key switch on and adjust it to our desired setting. As you review the procedures for Laboratory 2-8, you'll notice there will be some routine measurements that we are taking. The first one is going to be the power max, but also to ask you to do a power stability reading over a period of 1 hour. Now with this particular meter, I have the ability to adjust the durations and when it takes the samples, so I can collect all that information and I can do statistical analysis like standard deviation, mean, mode, and those type of statistics that you would require. Now we want to take our divergence measurements, and we've taken opportunity here to use our WinCam to capture that particular beam profile, and we're going to measure that at 2 different locations and do the calculations for divergence. One of the advantages of having a beam profiler like this one is I can observe TEM mode 00. And as I increase the drive current, we can observe TEM mode 01. So these are real-time tools. These are things you would actually use in the workplace, very powerful tools. In Lab 2-8, they ask that you look at pulsed energy. What I've done with this laser is I've inserted the mode locker so I'll be able to get a pulsed output. And that's what we're viewing on the screen here. We're using our photodetector supplied by the manufacturer to capture this pulse. And I'm looking at it on this digital oscilloscope. I can adjust my trigger to stabilize that a bit. I want to look at a signal here. I want to stabilize that with my trigger here. We're going to capture that. And I want to reposition it. Bring it down a bit, and then I'm going to adjust my volts per division and make that signal larger, and I can measure pulse repetition time, pulse repetition rate. I'm going to adjust my time base so I can look at a single pulse, and we should be able to look at rise time, fall time, the individual characteristics of this pulse, be able to complete our data table for Lab 2-8. In Laboratory 2-8, we looked at the neodymium YAG and the various perimeters we wanted to measure. And some possibilities, if we can use the beam profiler like here, that's a great opportunity for you and your students to get hands-on experience. So take advantage of all those opportunities to make you and your students a better laser technician.